Okay, welcome back to the Python tutorial. This is the second session of this series, and we're going to finish up what we started last week. So if you haven't watched last week's recording, that is required. So please come back, watch this another time after you've caught up with last week. So if you had technical difficulties last week, I hope we were able to set up a meeting time with you to work through them together. Okay, I am your same speaker as last week. My name is Julia Kent, and I'm a software engineer here at NCAR. And I will be taking you through these lessons as part of the Project Pythia and Pangeo efforts, just trying to get our software engineers to use the best practice tools in Python that are available to you. And before I begin, let's review the code of conduct. So by joining this Zoom call and participating in the tutorial seminar series, you've agreed to adopt these values and engage in respectful communication only. Any disrespectful remarks will have you removed from the call. The seminar is only an hour long, so if we're unable to give you the individual help you need to keep up during the session, I hope we can work together to get you up to speed before the next. I'll try to stop at certain points to make sure we're all together so I don't leave anyone behind, but I'm still trying to find that right balance of answering questions and not wanting to derail the conversation with questions that could wait until the end. There'll be some co-hosts in the chat that will try to answer all your questions as well. So some problems also that you have might require a separate meeting, perhaps where you share your screen and show us what's really going on. Okay, today's content is on the XDev tutorial site. And as always, I want to direct you to Stack Overflow, where you can ask some questions or find questions, and the Project Pythia, which has a great foundations book that'll take you through a lot of content similar to this. Okay, and then let's review where we were 2 weeks ago. So I'm going to close this out and open up a terminal for you here. Okay. So what we did 2 weeks ago, first let's move into the correct directory so we can kind of see. So for me, that was in documents, Python tutorial _22. And if I do an ls, you can see that we have a folder called data and a mysci.py script. Let's move into data just to check that it's there. Voila, my text file. And we can look into our mysci.py script as well. But first, let's activate our environment. So conda activate Python tutorial 22. Okay, and you can see that it is now activated. If this did not work for you, go back to last week's material. Also, try whatever solution might have worked for you last week. I know some of you had to do conda Python tutorial or just activate without the conda. There's a few different iterations of that. Okay, but now let's look at our script file. Okay, so we had printed hello world. We have our comment line, our print line, and then I did this print vim. I think that was something that we addressed during the questions at the end of the tutorial. If you don't have that line, it is fine, because what we're actually going to do today is delete all of this and turn it into something more useful. So I'm going to go ahead and do Control K, and Nano will just delete the full line. So we are now going to look at our data file, and we're going to use the Python open command and the Python readline functions. So here what we'll do is add a comment to describe what we're doing, which is read the data file. And then you need to direct Python to the path of your data file. So it's going to be in a string, again, with these quotes, and between the quotes, that's data and the name of our file, wxobs 2017 0821.txt. And now we get to open the file. So we're going to call it data file is open, file name R. And R is in a string. So these strings can be double or single quotes as long as you're consistent. And this R argument here after data file means read. You could also do like W for write if you wanted to change your data file, which I don't recommend doing in this instance, but there are definitely instances where you might want to change a data file to add another column of data that you calculated or something like that. And now we're going to print 4 lines of code, and we're going to do this with our print statement. Inside of print, we do data file dot read line, open close parentheses. And each time we call this function, we're going to move one more line down the file. Let's do it 4 times because I happen to know that that's the length of the header of this file. If you were exploring this on your own, you'd probably just start with the first, second, until you got to a line that was all tick marks or you started getting some data. So now we're printing these lines, and we're printing the value equal to our data file at that line, not the read line command. And then you have to close your data file for memory purposes. So we'll add another line that is data file dot close. And before we move on, I want to clarify the use of parentheses because I know this can be a little confusing. So like, why does the open have arguments inside of the parentheses, file name and R, and why does the data file has dot and then our function with the open close lines? So open here, a built-in function in Python. So it has these arguments, and the parentheses always follow functions, and sometimes they have arguments in them and sometimes they don't. And then Python objects have methods associated with them. So the data file is an object, and on this object you can call the function readline. So that dot, it's like object.function or object.method, I guess, to be a little bit more clear on the language. And then we have to access that function with the open close parentheses. I hope that didn't confuse anyone more. Okay, oh, you want my font size to be bigger? Let's see. Is that better for you? Just let me know in the chat. And if a co-host wants to clarify what I just said about the parentheses, please feel free. It can be a little hard to explain. Okay, so now let's run our new script. First time of the day. So if you don't remember how to do this, if you're on Nano, you're going to do Control X to exit. And then this little menu is going to pop up at the bottom, asking if you want to save. And I'm going to say yes with the Y command and then enter. And now let's run it with Python space mysci.py. And we got a line of data. We got these tick marks I was referring to, and we've got 2 lines of the header. Okay. So you'll notice that the first 3 columns are date, time, and temp out. It might be a little hard to read the way it's moving lines together because of the font size in the terminal. But this is the first column, the second, and then temp out on 2 lines. Okay. Do we have any questions at this point before we look at the whole data file? Okay, great. Let's go back into the script with nano mysci.py. Okay, so this time, instead of read line, we're going to use read. So you're going to keep these first 3 lines the same. Data file is open. And then here, I'm going to delete these lines. Data equals data file.read. This will read the entire file. And you still have to close it. Have a debug section to make sure it's working as expected. So first we'll print data. So this should print the entire file. So it's going to be very long. It's going to take up our entire terminal screen. But after that, just to kind of clarify or emphasize the difference between strings and object pointers, we're going to print the string data. Okay, I'll give you just a second to make sure you've copied this. And again, these commands are available on the NCAR Python tutorial site. Okay, I'm going to exit and run the script. Okay, so as expected, we get a whole bunch of data that you can scroll through as much as you have the patience for. And then we have the string data. Okay, and now we're going to do one more method of reading a data file. And this way is a little bit more Pythonic. What we're showing you, it lasts because it uses a with open statement, which can be a little bit, you know, it's just one more level of complexity. So I'm going to do nano mysci.py. Okay, so now instead of just opening the data file in one line like this, let me delete these 3 lines. We're going to do with open file name to read it as data file. And then here you're going to indent. So do that with 4 spaces. 1, 2, 3, 4. Data equals data file.read. And for our debug section, we no longer need to clarify that print statement. So this is a lot shorter. It's a lot cleaner. It also will automatically close the data file for you once you're done reading it, so you don't have to worry about the memory as much. So something that's a little bit tricky here, right, is the indentation on this line, the data equals data file dot read. Python is very sensitive to white space, and that can be helpful in some ways, as we'll talk about later. Like with for loops, you don't need an end for. Python just knows to read the indentations to know when you're within certain loops. But because of that, you need to make sure you're consistent. If you mix spaces and tabs or different numbers of spaces, Python is going to get confused, or rather it's like you're telling it that things are happening within other things when you don't mean for it to be that way. So it's pretty standard to do 4 spaces. You can get away with doing just a tab, but this can be complicated because if you run your Python script in multiple different environments, say you run it just here in your text editor on the terminal, you run it in Spider, in Visual Studio Code, all of these different Python platforms might have a different default value for the tab indexing. And if you haven't gone in and made them all identical, sometimes if you import code from different places, you're going to have some unexpected cleanup to do. So that's why I'm saying just to count to 4. And combined, these 2 lines, you can read them as, with our data file opened, I'd like to read it and call it data file. And then read the data file. Okay, let's run it and make sure that it's working as expected. There's no surprise syntax errors, spelling mistakes, you name it. Okay, we still have our abundance of data. Okay. Can you indent with just 1 space? I believe so. But that might make their code a little bit less readable to human eyes, as 1 space might not be as obvious to you as you think it is. But we can go ahead and try it just to show you. Sorry, the Zoom your screen sharing bar is hiding the top of my terminal, so I'm typing a little bit blind after I've cleared it. So it's best practice to do 4 spaces again, but just to show you that Python only cares that you're consistent. It still works. Again, please do 4. So I'll go in and that's 1, 2, 3, 4. Okay, so I want to let you know that Python is a dynamically typed language, which means that you don't have to explicitly specify the data types when you name a variable. Python can automatically figure it out by the nature of the data that you give it. It can kind of inherit what that class is, what methods can be applied to it, and so on. So the data here, which we can find out with a, okay, sorry, I'm in the middle of that. So we'll just open it again. We want to go find out what type our data is. And we're going to do that with print type data, like so. Okay. And then let's run it. It's a string. All of these numbers are strings, which means Python can't do math on them or do the kind of analysis you might want. It interprets them the same way it interprets a phrase that you might want it to print out or whatnot. So let's go and figure out how to make this a little bit more useful for us moving forward. But first, let's clean up and let's do our git commits again, remind ourselves how to do that. So open up your script and you can delete the debug section just as like good. Oh, sorry, I did Control X instead of Control K to delete the lines. So you do not need your kind of testing script in your final code that you save. So ideally each git revision, each git commit is something you might potentially want to go back to. And you don't need all your little tests in the debug there. Okay, so let's do a git status to see where we're at. Oh, it's thinking. Okay, so you might have something that looks slightly different because I know at the end of the last session, we did some git commits during the questions. And if you didn't stay for all those questions, yours might look slightly different, but basically we have a modified data script and we should all actually have a modified data script at this point. And let's add it. Let's do a commit. So git add mysci.py. Check your git status again. Here it's now a change to be committed. And let's commit it with a git commit -m for message. And then adding script file. Okay, let's check our git status. Everything's clean. And I'm going to do a clear to go back to the top and a git log. So you can see the commits we've made. So we all added our sample data file. This was after 2 p.m. 2 weeks ago. So some of you might have adding Python script and we should all now have adding script file. Okay, do we have any questions at this point? While I give you some time to put them in, I'm just gonna review what we've done so far. We covered 3 different methods of reading the data file. And the first, we use the Python readline method. This reads a single line from the function, and each time you use it, the next line is read. And the advantage of this is you can quickly see the nature of your data without bringing in like everything, taking up a lot of memory and a lot of your space, especially if you just want to see the header. You can imagine if you have to scroll through all that data to get back to the header to see what it looked like. Not fun. So this way you can see what each column refers to pretty quickly. The second method is the read function, which reads the entire data file at once. This is preferred over readline if that's exactly what you're trying to do. It doesn't lay out the organization of your file as much, but you frequently just want the whole data at some point. So that's great. And the third method is probably the most like Pythonic way, and we use the with context manager. The advantage of using a with block is that your file is automatically closed when you're done reading it, so easier cleanup and memory usage. And this is the way that you will probably see it done in a lot of examples. Okay, yes, the syntax. I will drop that in the chat real quick. So, okay. So first we just printed everything with print readline data file.readline, like so. Then we did data file.read, like this. And our third method was a context manager with. And apologies if the indexing doesn't come through in the Zoom chat box, but kind of like this. Okay, Jessica, nice question about Git. I'll cover that at the end. Or if a co-host wants to answer it now, that's great. But in terms of going back in older versions of Git, it is very doable, but is a little bit more complicated, could eat up more time than I want to give to it right now, because it can really take up as much time as we allow it to. But generally you would do something like git rebase and then a curly bracket for however many steps you want it to go back. Okay, and the preferred method is to use the with context manager. Or a combination of the read line to see the header and then the with context manager to open up the whole file, but not necessarily to print it. Okay, so our data is still all strings. So we're going to manipulate our data into a more usable format, a Python dictionary. Dictionaries are great because they allow you to use strings that are human readable to point to data that you're going to have Python deal with. And it's just a lot more intuitive than just kind of doing pure indexing. Okay. Yes, can a co-host help Tennille here? Okay. So the first thing we're going to do before we create our data dictionary is split this string up into lists. So let's do a little brief list tutorial. Okay, I'm going to do that down in a debug section here. Let's create a list called primary colors. And I'm going to do red, yellow, blue. You can make a list of any 3 things, any 7 things, whatever is your fancy. And to kind of see what this looks like to Python, let's do a print of primary colors. The important things to notice here are we have our variable name. It's equal to a list, which is the square brackets. And then each item in our list is separated by commas. In this example, the items in our list happen to be strings, but you could also do this with numbers, which are floats or integers, whichever you'd like. Again, you've probably already seen lists before in your experience, but we're just going to kind of hammer in the Python syntax and the things that are unique about lists in Python compared to MATLAB or some other language. Notably, MATLAB is 1 indexed and Python is 0 indexed. Many languages are 0 indexed, which means that your first index is actually, it starts at 0. It counts 0, 1, 2, 3 instead of 1, 2, 3. Let's explore this. Okay, so let's print primary colors 0 index, like so. And another interesting trick is if you want to print the last object of a list, so here would be blue, you could say 2 because it's 3 indices long, but you can also do -1. It will always give you the last item, no matter how long the list is. Okay, so we have our full list, and then we have red and then blue. And I'm going to go in again and show you a numbered list, and we'll do a little bit of list indexing for slice indexing. Okay, so I'm going to call this number list 0, 1, 2. I'm going to go all the way to 11. There are Python functions that will generate this for you, but they use packages, and we're trying to do this without external packages right now. So we just created a list, and we're doing this with numbers to really show you that this is the index of the number for this list they match. So if you want to get a range, you're going to do your starting value. We're going to start with 0, and then you do a colon, and then your end value. So in Python, you can actually do 3 values, which would be start, stop, step. You just do 1, it's not necessary. Spaces after the commas are not required, but they are considered good practice, again, for making things readable or just consistent, because you want to do the same thing across your code. Just kind of makes it nicer for you to read. So the first value in Python is inclusive, and the second value is exclusive. So we're going to start at the 0th index and read all the way up to the 10th, but we don't print that one. So if you want to start from the beginning, again, it's going to be like this. And just to clarify why it's different, if you start at the 1st index instead of the 0th index, you're going to get a different value, like so. Oh, I have invalid syntax somewhere. Okay, so now you can go on the debugging journey with me. Here's 10. List. Okay, let's leave again, see what it says. Okay, it's not the most helpful. Oh, I don't actually want to be redefining number list. I want to call up number list. So where are we? So this, we're going to actually change this to print number list, and we're calling up the index. Sorry about that. You can't define things as an index like that. Okay, you got to call it up from a list before you put in the index notation. Okay, so this should work now. Okay, there we go. So you'll see that our first index starts at 0 and our second one starts at 1, as expected. And I'm going to show you one more list tip before we go forward with applying it. So Python mysci.py. Oh, sorry, nano mysci.py. I'm going to show you that these two things are different from each other. So if you want to do, again, we're going to do this inside a print statement. our 0th index, like so, is different from if you do the slice indexing. So even though the slice indexing here starts at 0 and doesn't include 1, it is not identical to just grabbing the first index. And we can test this also with double equals to test if two things are identical to each other. Let me delete this space at the beginning here. Oh, and that space also, you do not want that space. The hotkey to bring it to the bottom line, let's see. I don't have all of them memorized. I know like Control A brings you to start of the line, Control B brings you to the end, Control K to delete. I'll just kind of paste a cheat sheet in the chat for you. And these can help you go to the end. So I think this one will work. Okay, so I think to end of buffer would be the alt slash, but you can explore that on your own. And there's similar shortcut commands for Vim as well. Okay, let's go test our list code. Okay, so notably, when you just grab one index, you get the value, which is 0. And when you do the slice indexing that points to a single value, your result is still a list that happens to only have one value. And these things are not equal to each other. Okay, now let's go ahead and apply it to our script. Go ahead and delete all of your list stuff. If you prefer, you can just comment it out. Okay, so we're going to keep our file name the same with this with open, but we're not going to just go ahead and read all of the data file at once. First, we are going to do a read line to move through the header. So this is going to look something like this. Oh. One, two, three, four. 4 underscore in range 3, because that's how long the header is, colon. 1, 2, 3, 4, and then index again, 1, 2, 3, 4, data file dot read line. Okay, so this is our first Python for loop. You're probably familiar with for loops from previous coding language, so we don't have to go too into detail about what is happening here, but I do want to cover the syntax. So a for loop iterates over a sequence. Here, our sequence is going to be range 3, and range is a new function for us here, and it's going to create something that's three long, because there's 3 in the header. And to really clarify what's happening, let's add a print statement in here. Print, and then your underscore. So it's like we're generating a list that goes 0, 1, 2, and in the first time it's index 0, the next time index 1, index 2. Some important things here, you need the colon before your indent. So both after data file and then after the range 3, you need a colon, and then to indent consistently 4 spaces. And another thing that might be different in Python from some other languages is you do not need an end for statement. You just tell Python when your for loop is ending, both by the range, like the construct, what's the word I'm looking for? Like the bounds in the for loop when you define it, and the consistent indenting tells Python when you're inside the for loop and when you're not. There's nothing else that would be communicated by an end for statement that isn't communicated by the indexing. So this is, again, one of those nice things, but part of why Python is so picky about your white space. So you do need to define a variable in order to move through. So that's why we use this underscore, but you might prefer to use N or I or any other character that you're most comfortable with. We use an underscore here because that's considered common practice in Python for throwaway variables that you don't actually want to save or look at later. Because you might later want I to represent index for some other reason. But the underscore, we only need this in this one instance, and we're done with it. So it's significant in that it is insignificant, if that makes sense. We're using it to kind of make it clear that we don't want to go to, and we don't want to worry about it too much. Okay, and this for loop sets us up so that we go through and call readline 3 times, and we move 3 lines down. And then the next thing we can do is actually read the entire data file. But first, let's make sure everything worked how we expected. With a Control X, save, and print. Okay, so we printed our underscore values as we move to the loop. As expected, 0, 1, 2. Okay, back into our script. Okay, so now we're going to, we're still within our with statement, but we're no longer in that for statement. So we're going to index 4 spaces. I know I said 4 a lot in different meanings. 1, 2, 3, 4. So now we're going to go through the data file line by line. So we're going to do that with 4. Line in data file. This is similar to underscore in range. So each line in our file that's left, this isn't going to look at those first 3. 1, 2, 3, 4. 1, 2, 3, 4. We're going to create a variable called datum. And it's going to be line dot split. So here, split is a new function. Split will take your string and divide it into components based on the argument that you give it. The default argument is white space, which is perfect for us because ours is split on white space. Some common other split methods that you might want to do. Sometimes you have a comma separated data set. You could do that with like so. You also might have data that's split along tabs. And so that would look like this. Split along tabs. Again, we're just splitting on white space. Okay, and we need to actually go up to the top of the script and initialize our data variable as an empty list. So go back up. There we go. Initialize my data variable. We're going to call it data. Open, close brackets. Okay, so you need to first create a list in Python that you then populate with data. And the way to populate it with data is with the append statement, which we're about to do. So for each datum from our split line, we are going to do data.append datum. So again, we've now done this line.split, which you can split on any character you like. You could split every time the letter Z comes up, whatever. But the most common is spaces, tabs, or commas. And we've appended data to our empty list, datum to our empty list data. So hopefully this helps you see why we created data as an empty list up here. So it starts out empty. We go through this once, we add data to it. We go through it again, we add data, and each time it becomes larger and larger as we move through our for loop. So we need to add these data to an existing list. It already has to be an object that has a class and all of these things that Python can understand before we start putting all of our data there. And let's add a for loop in here just to make sure things are working. And this will be one last for loop before we execute the code. For datum in data, print datum. Yes, datum itself is another list. So that's a good catch. We were going to kind of explore that a little bit and hopefully see that here. We can also show that with print type datum. Now it's going to print a lot of things. It's going to print each line, and then it's going to print list, and then each line and list. Okay, so you can see we have a line of data that starts with date, time, temperature out, a bunch of other things based on the header, and then it tells you what class it is, and it's a list. Okay, so far we've covered a lot. We initialized an empty list with square brackets. We covered for loop syntax, dummy variables with the underscore, and then we used the range, the split, and append functions. So now that we have our data in a list, instead of just some random numbers or strings, let's practice list indexing again before we move on. Do it clear. Okay, I'm going to delete my debug section and start over. Okay, so first we want to print the 10th index of data. Any guesses on what that number is going to be inside the brackets here? It is not 10, it is 9. Nice job, everybody. And we want to print the last one. Again, that is going to be with -1. Okay, I see I have an extra A up here. And if we want to do the list indexing again, we can do the slice like so. So to get the first 10 lines of code, we can do print data :10. You don't actually need to say 0:10. If you just put the colon there, it starts at the default spot, which is beginning. Like so. Okay, let's print this out. Okay, so we've got a lot of lines of data. It's hard to exactly know what these are. Let's go back into your script. Okay, so we no longer need to call this print statement to check that our range function is going as we expected. Okay, so if you're unable to append your data list because Python doesn't see it as a list, potentially that's because you have an extraneous line somewhere in your code that is specifying specifying data to be something other than your list. So let me kind of look back at what we have here. If you still have the line data equals data file dot read under your with open statement, that will tell Python that data is now the string that is all of your data. But we are now trying to turn it into a list of lists of strings. So if you have that line, go and delete it, and all of your problems should go away. Okay, maybe we should do a few more list indexing examples here. Say you want to just print every other line of data. You could do ::2. We do every other line. There's a few things I want to show you that don't work. That could be tricky. And some of this has to do with list indexing. So each index of data is itself a list. So if you want to call up the first element of the first list, you would do that by first calling up your first list. So this points to your new object, which is a list, and then that object gets indexed like this. Now it is not, we're not going to do print data of 0, and then we don't nest the brackets like so. You call up the bracket or to index to create your list, and then you point to that again. I'll go ahead and run that line just to show you that it gives us a syntax error. Okay, so it doesn't like it. And so it won't even run the other code, because first Python will look at your entire script and make sure it can read it. And then it'll go through line by line. So let's delete that line and try again. Okay, voila. We've printed a bunch of stuff. Okay, I know we're almost at time. There's one more thing I want to show you with list indexing, and then next week we'll actually take our list and put it into a dictionary. Okay, so another thing that will not work is if you want to get the fourth element from each list from 5 to 8, like this, this will not work. Let's see why. Okay, list index out of range. Now, the reason this happens is because 5 to 8 points to your new list object that has 3, what used to be 5, 6, and 7 is now 0, 1, and 2, and it still has those lists, and then it's going to try to get the fourth index from that, which would also point to, hypothetically, if your list was long enough, another full line. It will not go through and find the fourth index of each list in those lists. We can get that. Usually you would use a for loop to get that. But this is not how you'll do that. So I just want to show you that. Okay, so let's end today's session by cleaning up our code and git committing it. So go in and delete your debugs. Okay, and then git add mysci.py, git commit -m parsing file. Okay, so we did a good job reading in and parsing our file. Git log to see everything there. Okay, thank you for attending today. That's going to conclude the second lesson of the tutorial series. So in this session today, we saved the variables. We created our list of lists. We looked at 3 different ways of opening a data file, and we've covered a lot of different functions. We did the with, open, read line, read, split. And you learned about floats, strings, lists. And this is the first time we've gone through and cleaned up our code a little bit. So in 2 weeks' time, we will structure this into a data dictionary, which we can then use to do some analysis work. Again, thank you. If you had any technical issues, please reach out and make sure we can get that all fixed up before you join us again on June 23rd. Feel free to leave now. I know we're at the hour, but I'll stay on the line a little bit longer to get some questions. Okay, first I see Emma's question. Can you go back to the nano and see where we left off with our code? Yes, let me just leave that screen open of where we're at now. So we have our data list initialization. We have our file name variable pointing to the path string where our data is. We use the with open context. We use the with context manager to open the data file. We read the first 3 lines with read line, and then we read the rest of it with line.split and append our data to the list. Are lists what you would use for multidimensional numerical arrays, or are there other constructs for doing math calculations? Lists are the building blocks of those other constructions that might be more intuitive or helpful for you, such as being able to grab the fourth column from every list, because the list indexing here will only let you move through rows and then through columns in a way. So there are other Python classes that are a little bit more advanced, but ultimately they're built on list and list indexing. So we're going to cover this first, and then later we'll teach you how to use NumPy, Pandas, and Xray, which are 3 packages all kind of built on each other. That'll be very helpful for multidimensional numerical arrays. And lists are very, they're very basic, so they also can accept like the most different types of data. So it could be strings, like we did with the primary colors example, where some of the other data types might be might have stricter applications and the stricter ways that you can use them. Okay. Were we able to fix the issue with running the Python command? Yes, you cannot run the Python. So if you're using this, following along the tutorial on Spider or a different Python interface instead of using the terminal, it's important to make sure that you are using your terminal to run the terminal commands and not a Python command line to run terminal commands, because that will expect Python. And so certain things will not work. There are some Linux commands that Python knows how to read, or that you can download a package to tell Python how to read, but ultimately that's clunkier to use a function to run a terminal in Python, but you have to go through the Python interpreter and then back to Python to run the Python script, then starting in the terminal. If you're more comfortable with the command line, I'm sure your user interface just has a run code button that you can do. Okay, thank you, everybody. And I'll see you again on June 23rd.